Yeah, 0 and -1, so we know the pattern here. Okay, so for cysteine to have a charge of -1, the pH is going to equal 9.55. So it's really, if you said like 8.33 to 10.6, that gave you credit for that. Yeah, that's the -1. For the -2 is between 10.78, and this one turned out to be, let's see, we did the calculation, that was 11.6 up here. And then for this one, the starting point, that was 1.36. Okay, so for the -2 charge, if you said 11.6 or between 10.78 to 12, I give you credit for that. Okay, so since the question stated at what pH does cysteine have a negative charge, so I gave you full credit if you said basically between a pH of 8.3 and above. And then for the charge of cysteine, then you want to show either this structure or that structure to match the charge. Okay, so it turns out that I don't really know for sure since I've never had my hair permed, but I know they use something to change the pH of your hair. They also use oxidizing and reducing agents during the perm process, I've heard. Okay, so anyway, what's forming are the sulfur-sulfur bonds, and if this is let's say that this is a strand of hair, and there's a sulfur here, this is the SH, here's another SH. Okay, so what you're trying to do is get the sulfur and sulfur to bond together, so you can do that. Here's this disulfide bond, and by doing that, note that you're putting a kink or a curl in your hair by doing that. And I guess the reverse, if you want to get your hair straightened, if you have curly hair, want to get it straightened, you have to break the sulfur-sulfur bond and then straighten it out, and then reform or not reform, but then form a sulfur-hydrogen bond, where that sulfur-containing amino acid. Okay. Oh, for that one, okay, so yeah, question B says the pH of hair is 5. What is the charge of hair at this pH? So there's one way you can answer that question is by looking at your titration curve, which you drew in part A. So note that at pH 5, the charge equals 0. And then for the second part, under normal conditions, what do you want the charge on your hair to be? Well, you want it to be 0, because if the charge on your hair is, say, positive, so if your hair strand is positive, you have another hair strand which is positive, what do two like charges do? They repel each other, and you don't want your hair to look like that usually in the morning or afternoon or evening. So then for part C, what should the pH of pH balanced shampoo be? And the pH of pH balanced shampoo should be, about 5. Since that matches the normal pH of the hair. Okay, so you guys are going to be scientists and engineers and health professionals, and certainly doctors are always looking at tests because they're always ordering tests when you go to see the doctor. So whether they're blood tests or some sort of test, then you get the test. Those tests are always quantified by numbers, and you get to figure what those numbers mean. So when you look at these numbers on this titration curve, or those numbers from from question 4, we got to figure out what those numbers mean. So whether it's a pKa or a pH, those numbers are meaningful, and we got to figure out what those numbers mean, as well as what do those quantities mean. So in other words, what does pKa mean, or what does Ka mean? So when you're a doctor and you get back those tests, if say your triglycerides are at 10, and of course they always give a range too. It should be pretty, say, 2 and 8. Well, that means 10 is too high. You got to do something to get that number back until you have a normal range again. Yeah, so although I don't like seeing the doctor, whenever I see the doctor for my annual physical, they always take a blood test, take these tests. I always ask them to give me a copy of the results so I can figure out what those numbers mean. Because I don't think the doctor, they just look for the star. If it's out of range, they see a star, so the doctor's just looking for the thing that just started. And then the star, he goes, oh, what's going on there? He says, no, I don't think he looks at the other numbers. It's too busy. Okay, are there any other questions on the exam? No questions on question 1 or 2? No? Okay, so I guess we're ready to move on. So last week in lab, you made some batteries. So let's review a few of the concepts we covered in lab last week today. And while this projection is going, I just want to make another comment about your exam. So if you did well in your exam, that's great. I'm really happy that you did well. If you didn't do too well in the exam, remember that this exam is only worth 10% of your overall course grade. Which means that 90% of your grade, that is the rest of your grade, is based on something else. So there are many ways I use to evaluate what you learned in Chem1B this semester. So if you didn't do too well in this exam, there are opportunities in lab and in quizzes. And by talking to me, if you want to talk to me, that I can use to figure out how much you know about Chem1B so far this semester. So I'm hoping by the end of the semester you'll have a very good to excellent understanding of the topics we covered, and then you'll get the grade that you want to get in Chem1B. So we only have 4 more weeks left in Chem1B. So after electrochemistry, we're going to cover nuclear chemistry. And then we'll spend a little bit of time on coordination chemistry and transition metals, and then we're going to review for the final exam. And it looks like the final exam is scheduled for Tuesday, May 29th, which is 4 weeks from today, from 8 to 11. And then the final exam is worth 20% of your overall course grade. And the final exam will consist of 2 parts. One part will be a take-home part, which you can work on either by yourself or with other students in this class. The in-class portion of the final exam will be the same length as a hour and 15-minute exam. Okay, so there'll be 3 or 4 questions on that, and it'll be 3 cases. So I'll try to we'll try to limit the torture of the final exam. Okay. So we did this in lab last week. You connect one metal to another metal with a wire. What happens? So you said that electrons are going to move from one metal to the other metal through the wire. And in which direction does the electrons from the less active metal to the more active metal? From the more active metal to the less active metal? Or does it matter? Yes, it's going to go from the more active metal to the less active metal, because the more active metal more easily loses electrons. Okay, so what about here? So note that we know that copper is sort of this red colored metal. You put copper into a zinc 2 plus solution, what happens, if anything? I'm not sure if you remember doing this from Chem1A and the Chem1A lab.
It oxidizes?
What's it?
Metal rust.
Which metal?
The copper metal.
So you're saying that when you put copper into a zinc ion solution, so here's your zinc ion solution. You're saying that the copper is oxidized to copper 2 plus.
The zinc loses its electrons.
You're saying that the zinc is being reduced to zinc metal. Okay, so let's keep this in mind, because here's the other part. A piece of zinc metal is placed in the copper 2 plus solution. What happens and why? So in this case here, copper 2 plus solution is blue. I'm not quite sure what happened with the slide here. Anyway, then the zinc is the zinc color. Here's zinc and here's your copper. Okay, so if the zinc is placed in the copper 2 plus, what happens here, if anything? Nothing happens. Okay, so to help us answer this question, let's review the activity series. Again, this is all the way back from Chem1A. So, in the the activity series of metal, you take your metal and then your metal ion. Does a metal behave like an oxidizing agent or reducing agent? So, does a metal gain electrons or does it lose electrons? Yes, we know that metals, these lose the electrons. So if it loses electrons, that means the metal itself is being oxidized, which means is it an oxidizing agent or reducing agent? Yes, that means the metal is reducing agent. This is, I know this is confusing, but I'm not sure who's the person who came up with, oxidizing agent, reducing agent, which means that a metal ion is this the oxidizing agent or reducing agent? Okay, this is an oxidizing agent. Let's compare zinc to copper. Which one is more active? Okay, so this is the activity series is shown on page 100. This is on page 117, figure 4.14. It turns out that zinc is more active than copper. So let's put zinc above copper. Now, this in Chem1A we said that this is how we use the activity series. So a metal will react with any metal ion below it on the table. Okay, so that means that zinc will react with copper 2 plus. However, copper will not react with zinc 2 plus. Okay, so when you put copper in a zinc ion solution, is anything going to happen? No. Yeah, so we should see no reaction occurring here. And in this case here, will we see anything happen? Yes. So what's going to happen?
The copper is going to
So we said that zinc is going to react with the copper 2 plus. Okay, so if zinc reacts with copper 2 plus, what's going to be the products of this reaction? It's going to be copper metal and
Zinc ions.
zinc ion. So note that the zinc is being oxidized or reduced. Yeah, so zinc is being oxidized. And then the copper 2 plus is being reduced. Now we can tell that a reaction is occurring because if copper is being reduced to copper metal, where do we see the copper metal forming? Yeah, we see that on the form of the surface of the zinc. So what we see is that copper metal is forming on the surface of the zinc. So if you leave that zinc in that copper metal, that copper ion solution long enough, it turns that red color, that red copper color. And then what happens too is that the zinc, this is going to form zinc ion. So we would see zinc ion also in the solution. Okay, so